Good morning, everyone. Today, our group will be presenting cloud computing project where we designed a cloud solution for TechShop, an online technology retail company using Amazon Web Services. My name is Danya Ali, and I'll begin by introducing the business, explaining why we chose a cloud-based infrastructure, and sharing my personal reflection before my teammates continue with the AWS implementation. Before we begin, here is a quick overview of our presentation. We will first introduce the business and explain our cloud strategy, followed by the AWS services selected and the estimated cloud costs. Next, we will demonstrate the AWS implementation, including networking, storage, databases, monitoring, and load balancing. Finally, we'll walk through the overall architecture and conclude with our key learnings and reflection. TechShop is an online retailer that sells a wide range of consumer electronics, including laptops, smartphones, gaming systems, smart home devices, and accessories. Since the business operates entirely through its e-commerce website, customers need to be able to browse products, place orders, and track deliveries at any time. Because of this, the website is the core of the business and must remain fast, reliable, and available 24 hours a day, 7 days a week. Therefore, when designing our solution, we focused on creating an infrastructure that could provide high availability, strong performance, and the ability to handle increasing customer traffic as the business grows. After analyzing the business requirements, we decided that a fully cloud-based infrastructure using AWS was the most suitable option. Cloud computing allows TechShop to scale resources automatically during busy periods, such as sale events, without purchasing additional hardware. It is also more cost efficient because the company only pays for the resources it uses. AWS improves availability by deploying services across multiple availability zones, reducing the risk of downtime. Security is strengthened through services such as identity and access management, security groups, and private subnets. Since TechShop is a new online business with no existing on-premises infrastructure, a fully cloud-based solution was more practical than a hybrid environment. Working on this project helped me develop a much better understanding of cloud computing and how AWS services are used to support modern businesses. My main responsibility was researching and preparing for the business report, which improved my research, analytical, and technical writing skills. Although I wasn't directly involved in implementing the AWS environment, reviewing the implementations with my team allowed me to understand how services such as Amazon EC2, VPC, RDS, CloudWatch, autoscaling, and load balancing work together to build a secure, scalable, and highly available cloud infrastructure. Overall, this project has given me valuable knowledge of cloud technologies and their real-world business applications.
Here's the full list of AWS services behind TechShop. Amazon EC2 hosts our web server and application. Amazon VPC gives us a secure, isolated network. Security Groups acts as a virtual firewall controlling inbound and outbound traffic. Amazon RDS, running MySQL, is our managed relational database. Amazon EBS provides block storage with snapshot support. CloudWatch monitors performance, logs, and alarms. Autoscaling automatically adjusts EC2 capacity based on demand. And an application load balancer distributes incoming traffic across multiple EC2 instances. Here's our estimated monthly cost breakdown. EC2 costs about $8 to $9 a month. The two NAT gateways are actually our largest cost component at $65 to $70. That's the trade-off for having redundant private subnet internet access across two availability zones. EBS storage is under $2. RDS is $12 to $15. The application load balancer runs $16 to $18. Data transfer and CloudWatch monitoring add less than $2 combined. All in, we're looking at roughly $105 to $115 a month, practically offset by our $50 AWS Learner Lab credit. The takeaway: AWS lets TechShop scale efficiently, stay secure, and achieve high availability while keeping costs predictable and manageable. Moving on to the AWS architecture. Users access the TechShop website through the internet, which hits our application load balancer. Though in our build, we're routing directly to EC2 rather than through an ALB, since load balancing wasn't configured this round, our EC2 web servers sit in public subnets across two availability zones. RDS, storing our application and customer data, sits in the private subnets for security. EBS provides persistent storage with snapshot backups, and CloudWatch monitors performance across the whole system, feeding into autoscaling if the traffic grows. Working on this project gave me a much better understanding of how different AWS services work together to create a complete cloud solution. Instead of viewing services like EC2, VPC, RDS, autoscaling, CloudWatch, and the application load balancer separately, I learned how they all connect to provide a secure, scalable, and highly available architecture. While preparing the report and presentation, I had to understand the entire system well enough to explain it clearly. This helped me learn how traffic flows through the architecture, how data is securely stored, and why monitoring and automatic scaling are important for maintaining performance. I also gained a better understanding of cloud costs and how choosing the right AWS services can balance performance, reliability, and budget. One of the biggest lessons we learned was the importance of documenting work as we progress. Recreating screenshots and evidence after was the most time consuming part of the contribution. Overall, this project strengthened both my understanding of AWS cloud architecture and my technical documentation and presentation skills.
Hello, my name is Shariar Nasir, and here in 2.1 Amazon VPC, we are creating a VPC with the name Tech Shop and two public and two private subnets across two areas. And in this one, we have initialized it, and as you can see, it is successfully created. And after this, we are moving to EC2 the instance, and here we are choosing an instance like choosing the Linux or what kind of server we are going to use, and the instance type with like which is T2 micro and access for SSH. And after that, here we have, as you can see, launched our VPC public subnet with a public IP auto assigned, and security group allows SSH port 22 from which the requests will be made, and for HTTP 80 port 80 which will be for everyone. After this, we have here to Amazon EC2 settings which we are creating like running the tech shop web server running with 2 by 2 status check passed. We need to wait for the check to be passed because it has to be 2 by 2, otherwise means it's still initializing. After that, here we have terminated protection enable. The instant can be accidentally deleted. Like you have to physically go into the actions for place and there choose instance type, and then you can uh, make it work for you. And after that, we are changing the instant type as well. So the instant type is changed to T2 micro 2 versus T2 small. And then we are trying the web server configuration so we can control the EC2 from our computer, which is like available in AWS. For that, you have to go to your terminal and do some commands or things like that so you can make it work. And when it will start working, you will see a sparrow like this, as you can see in the portal. After that, we are just changing some things like creating a GP volume and volume attached with the snapshot in place for background and recovery. In this, I learned all about what we can do to make VPC and EC2 and its balancement, and how we can make it for better for ourselves, like making it more usable, more reliable, and less spending less money on it.
So in this slide, we are talking about Amazon RDS MySQL setup. So for the database layer, I used Amazon RDS with my SQL engine to power the TechShop project inventory. On the left side, you can see the engine selection screen where I choose my SQL under the full configuration option, giving me control over sizing, storage, and backups. On the right, I selected a multi-AZ deployment which automatically replicates the database across two availability zones. This ensures high availability. If the primary instance fails, RES can fade over to the standby with minimal downtime. So this slide 2.5 is about the Amazon RDS MySQL securities and integrations. Security was a key focus here. I disabled public access to the database, meaning it can't be reached directly from the internet. Only resources inside the VPC can connect to it. I created a dedicated security group, RDSSG, to control exactly which traffic is allowed in. On the right, you can see the database PI file where I use SQL Alchemy to connect our fast API application to the RDS endpoint, keeping the connection secure and internal to the VPC. So here we have discussed the Amazon RDS MySQL verifications. To confirm everything was working correctly, I connected directly to the TechShop DB instance over SSH from the EC2 terminal. From there, I created a products table with columns for ID, name, price, and quantity, and inserted sample inventory data, a laptop, a mouse, and a keyboard. Running a select query confirmed the data was stored correctly, proving that the database was fully functional and ready to serve the application. So on this slide, 2.6 monitoring and scaling the CloudWatch, we're talking about for the visibility into performance. I set up Amazon CloudWatch to monitor the TechShop web server. On the left, you can see the key metrics being tracked: CPU credit usage, network packets, and disk operations, giving insight into how the instance is performing over time. On the right is the CloudWatch console where alarms and dashboards can be configured. This monitoring setup is what would drive future scaling decisions, alerting us if resources used spikes beyond expected thresholds. So in this last slide, application verifications, finally this slide shows the full stack working end to end. On the left, the Apex default page confirms the web server is up and responding on its public IP. On the right side is the live texture inventory application successfully putting real product data, the laptop, mouse, and keyboard directly from the RDS database. This confirms that every layer of the architecture from the EC2 web server to the RDS database is properly connected and functioning together. So my personal reflection about this project is like the TechShop project taught me that in cloud infrastructures, security, availability, and cost all have to work together, not separately. Troubleshooting the EC2 to database connection really deepened by understanding of networking. Overall, this project made AWS concepts feel real, not just theoretical. So, in a conclusion, I would say that this project shows how tech shop, our fictional online electronics retailer, can use AWS to build infrastructures that's secure, scalable, and cost effective. By combining a segmented VPC EC2 for web hosting, RDS for reliable data storage, and auto scaling with load balancing, TechShop is well positioned to handle unpredictable e-commerce traffic while keeping costs high to actual usage. This is an outcome that would be far harder and far more expensive to achieve with a traditional on-premises setup. Overall, this project reflects how thoughtful cloud architecture directly supports real business goals.